So this video we're going to cover the notes section. The last video was the review stuff that we'd covered before. This is the new stuff. So, where's my pen? Here it is. Okay. I went on and filled these things out ahead of time just to hopefully save some time. So, notes number 1. What 3 things does this circle have? And we're looking at this guy right here. Well, it's kind of it's kind of an open-ended question. You could probably pick out more than 3 things, but the 3 things that we care about that are drawn on here are, 1, we have, well, I should have put chord first. So first we have a chord. We have chord AB, and again, a chord is just a line segment that goes end to end on a circle. So we got chord AB. And every time you have a chord, you're going to have a minor arc, and then you're going to have a major arc, because there's a short way to get to those 2 points, and then there's a long way to get to those 2 points. Unless your chord went through the center, making it the diameter, then both arcs would be exactly half. But anyway, so you have a chord, you have a minor arc, and then you have a major arc. Notes part number 2 says, what do we notice about the chord and the minor arc? What do we notice about the chord AB and this minor arc AB? Both have endpoints at AB. That will come into play just a little bit later, but what do we notice about the chord and the minor arc? They both have the same endpoints. The reason it's not the major arc is because the major arc means that we would have some other point like X out here, so it would be A, X, B, so they wouldn't have the same endpoints. So yeah, both have endpoints at A and B. So number 3 says, and I'm just now noticing that this is really thick ink and it's starting to kind of bleed through, so if it makes it hard to read, I'll fix that next time. So if chord AB, so it's hard to read, here's A and here's B, and then that says C and that says D. So if chord AB, so if this, oh, that was not a straight line, if that chord equals this chord, meaning if chord AB and chord CD are the same distance, what would you say is true about the measure of arc AB? So the arc AB is this guy, and the measure of arc CD. So if AB equals CD, the chords that is, what would we say about arc AB and arc CD? Well, we would say the measure of arc AB is equal to the measure of arc CD. If the chords of these 2 different arcs are the same length, then the minor arcs themselves are going to be the same measurement. And that goes back to well, what does that go back to? Maybe previous notes on a different day. I guess they're not on here. Okay, so part 4 says chords BC. So again, it's B. There's a BC, and here's chord DE. That's something like that. And then you can't really see it, but it has these 2 parallel lines just like that. So chords BC and DE are parallel. So BC and DE, these are 2 parallel lines. Parallel chords inside of a circle are congruent. So that is actually not true. I don't know why that's in there. Parallel chords do not have to be congruent. So I'm going to take this part out that does not always have to be true. They do not have to be congruent if they're parallel, because DE could be right here, and then that would be longer, so it wouldn't be congruent. But the main thing that you need to take away from number 4 is that if you have two parallel chords, in this case BC and DE, chords BC and DE are parallel. This means, and again, we could scratch this out because this had some errors in it. This means that the arcs between the two are congruent. So we've got we've got chord BC, and here we've got chord DE. So here is the space in between them. So arc DB is going to equal arc CE. Because again, these are two parallel chords. The arcs in between parallel chords are equal. That means arc DB is equal to arc CE, because these are the arcs that fall between these two parallel lines. That means, again, BD and arc CE are going to be equal. And then lastly, and after this we'll just do a couple examples. Today's lesson tells us 3 things. The first thing it tells us, congruent, which means equal size and shape, they're the exact same. Congruent chords have congruent arcs. That's going back up to here. So AB and CD were congruent, meaning they're the exact same size and shape. They're both straight line of a certain distance. That means arc AB is going to be congruent to arc CD. So number 3, that's kind of where this comes in. On the flip side of that, congruent arcs have congruent chords. So if you looked at this picture, and if I told you, just ignore that. If I said arc AB, let's say arc AB is, let's just say 50 degrees. If I said arc CD was also 50 degrees, that means the chords connecting the two endpoints of the two different arcs are going to be equal as well. So if arc AB and arc CD are congruent, then that means the chord AB and chord CD are congruent. So congruent chords have congruent arcs have congruent chords, and then this last little bit right here is what number 3 is about. Arcs that fall in between parallel chords are congruent. So chord BC, chord DE, these are parallel. The arc that falls in between them, the arcs that fall in between them are going to be congruent, meaning the exact same measurement and shape. We'll do some examples.